Hello, everyone. This is Ziad Sabah. I'm the moderator of this session. In this session, we'll talk about the ML experimentation and ML metrics logging tools, which become very popular nowadays. So they help researchers and engineers to keep track of metrics, but they lack reproducibility since source code and data need to be version controlled separately from log metrics. So using DVC, ML metrics can be tracked together with code, data, and ML models in Git repos. I'm happy to introduce Dmitry Petrov, who is the co-founder and CEO of Iterative Inc. and the creator of DVC.org, which is a Git for machine learning, simply. Also, he is ex-data scientist at Microsoft, and he has a PhD in computer science. Without further ado, over to you, Dmitry.
Thank you, Said. Very happy to be here in this event in San Francisco Bay Area. I am actually in the Bay Area, if it is important these days. So I will be talking about MLOps principles, how we can apply those principles to our experimentation phase, and how we can benefit from the DevOps tools and principles when we do experiments. By experiments, I mean how we track the experiments, so the metrics, source code, data, how we track checkpoints in deep learning projects. And those are features that we are recently implemented in DVC, and I will show you how to use this. Let me share my slide. So the first part of the talk is going to be about DVC, kind of an intro to DVC, just to better understand why we use those principles and how it helps in the experiments. The second part is live demo. It's kind of practical part. I'll show you how this functionality works in real life. A little bit about myself. About 10 years ago, I switched from to the industry. I was data scientist at Microsoft Bing, when I have seen how large teams are building models, how they collaborate on AI projects, and now we build tools for machine learning. So I was a creator of DVC, the open source project DVC, and we have today CML, another open source project, and we created a startup to provide solution for companies, for enterprises. So first, start with DVC and what principles we use for building the tool. Our big belief is MLOps, machine learning, is a part of software engineering and DevOps. We need to use the same principles as people use in those disciplines. I'm not saying it's the same. It's very different. It requires a different mindset. It requires different skills. But our job is to kind of cover the gap, to bring those the new functionality of ML processes to the engineering toolset and reuse the engineering toolset in ML workflow. What does it mean? It means that for automation, we need to use command line interfaces because this way it becomes very easy to be part of your software engineering stack. It's easy to engineering team to deploy your result, to automate your result. It's easy for you as data scientist to do some automation, to enable like CI/CD process, auto training in a cloud, hyperparameter tuning, and using all the benefits of the existing ecosystem like Git, clouds, CI/CD, and so far and so on. So DVC does many things, actually. It's called data version control, but it does way more than just data versioning. First of all, yes, it's data versioning. This is the way how you can put large data set in your repository, because Git doesn't work for large data files, right, or large models. DVC can help you to do this. It does not mean DVC puts data to the Git repository. It means it's kind of orchestrates your code repository and your cloud storages like S3, NFS servers, FTP, Azure, or any server that you use. Data model versioning and metrics, it's another functionality of DVC. You can version your plots, metrics, navigating your experiment through models. Pipeline is another important part. We won't be covering this today. And experiment tracking is a new functionality which was released less than a month ago in March of this year, which includes experiment tracking and also checkpoints functionality for the deep learning scenarios. So let's look briefly how DVC looks like. You can easily install DVC through Python if you prefer to use Python, or you can just download software from the website, from Brew, for example, or just a package for Windows or Linux. It works with any language and in any system. And then you initialize DVC in your Git repository. You need to specify the storage. It's kind of remote. We have a concept of data remote in addition to your code remote. And then data versioning. In this way, you enable your data versioning. So now you can say DVC add a directory or a file. It can be like 10 gigabytes directory or maybe 100 gigabyte directory with millions of images or just one large file. DVC creates meta information that you're supposed to track in a Git and version in a Git, but the data goes to the cloud. So DVC push will copy data from your machine to the cloud directory that you specified in the previous step. So once you created the repository, committed your result, committed your metafile, any team member can clone the repository and pull all the data, models, metrics, and anything that you have created on your machine or in a cloud. So that's how it works in kind of conceptual level. On one side, you have your code remote and code and metafiles. On another side, on the right side, data remote with the actual data. And DVC works on your Git repository and orchestrate those two pieces by the metafile. So pipeline is just kind of a command that you run. But in simple cases, just one single command, like Python train with dependency specified, or maybe not. But in some cases, it might be a complicated pipeline with 5, 10, 50 steps. So we won't go deeper here, but what is important, it's also a metafile. It creates a metafile that can be tracked and versioned by Git as well. Model versioning includes different pieces. First is a summary metric. It's about your kind of performance of your model. And you can look at the difference. You can look at your metrics. And DVC gives you a way how to navigate in your repository through the metrics. Because code diff, it's not useful, right? If you do like diff for your training script, it will say, all right, one line was changed, but all right, but how, what was the effect of the model, right? It's not clear from the simple change. DVC gives you ability to do the metrics kind of data-driven diff. When you can say diff with my master branch, do diff between version 2.1 and 2.3, and you'll see the table with all the metrics you have, and what was the value of the metrics and what was the change. So this diff becomes data driven. DVC has the same functionality with plots. If a plot was generated if data for the plot was generated to JSON file or TSV file or CSV, you can do the same kind of similar diffs for plots. What is the difference between my current plot, my current model, and my model in master branch? In some cases, it means production. And HTML file will be generated, so you can look at your plots. So this is how you can productionize your model, how to get model from your repository in a one line, how to get model from the Python code. We won't be covering this part. But the beauty of this approach is when you work with Git as a storage, as a database, if you wish, for your models and your experiments and metrics, you can easily use another tools from Git ecosystem, from DevOps ecosystem, such as CI/CD. So we have another project, cml.dev. It's a simple library which helps you to generate reports for a pull request, and it helps you also orchestrate resources from cloud, like training on the cloud. And this is what you can create with help of DVC and the library. This is an example of metrics-driven or model-driven auto-report and GitHub pull request. So you can set up your CI/CD in a way that when someone made a change in a model, CI/CD run tests automatically and generates your quantitative metrics. How this model was changed, what was the difference in plots, and all the tables that you've seen on the previous slides with DVC metrics div, DVC plots div can be easily put into the report, and the entire team can see how your improvement looks like. So yeah, and workflow, it's relatively easy to specify this workflow in GitHub. It's literally like 10 lines of code, and it will be run automatically and generate this automatically. All right, let's jump to the experiments. When we implement this DVC, the functionality I mentioned before, people start using this functionality a lot for kind of sharing experiments, not sharing experiments, sorry, for sharing result of their modeling. It become a collaboration tool for many teams when you do your modeling job, and once you're done, you share your model, maybe change labels with the other team members. You can just clone repository or run a proper CI/CD process, but your team members can get the result. It didn't fit well to experimentation phase when you need to run hundreds of the experiments, dozens, hundreds, or even thousands. So we decided to implement this experimentation functionality in DVC. Usually a Git commit become a problem because you need to run additional commands all the time. It overpollutes your kind of namespace of your branches and commits, so people don't want to do this. And we automated this in a way that it is now hidden under the hood in DVC. And checkpoints, model checkpoints, it's very important pattern today in a deep learning world. And we put quite some effort to instrument and implement this functionality. So let me show you how it looks like. So here I have actually, sorry. Where is my, yeah. Here I will clone some repository. It's going to be a Git repository with DVC. Git clone. And here you go. This is a repository. It's very small, 1 megabyte. It contains only source code and meta information. For example, if you look at the data directory, it's almost empty. There is only one data file here, that is a metafile for DVC. However, when you run DVC pull, it will bring all the data to your workspace. Data comes from the storage that someone specified when the repository was created. And you'll see the entire data set, intermediate result, the final model in your workspace, here in your machine. So that's how it looks like. It's more or less the same. The only difference, you actually have data now. So the size of the repository is 155 megabytes, which is not a big size, but in reality, you probably work on a gigabyte scale or maybe hundreds of gigabyte scale. So this is usually when it becomes a problem. But with 100 megabytes, we can show the idea behind. So we got data in this directory. We got the model. So here, and now you can run your experiments and reproduce all the results. Actually, it's not needed now because the model is here. But if you run DVC exp-run, DVC will say there is nothing to reproduce. Everything is here. So just use this. You can do like force, which means no, still let's retrain the model. The data set is small. Training and processing happens fast. Let's just reproduce this. So you see, DVC does this in several steps. So first prepare, now featureization, and then training. The pipeline, I've shown, you have seen the meta information for data, right? Data DVC file I showed you before. There is a file for pipeline. This is how DVC reproduce the result. There are several steps in this project with all the commands. You see, Python, prepare, data XML, and etc. So, all right, we just did repro. There's nothing to reproduce now. DVC exp show you can see the metrics and hyperparameters in a single table here. So this is your master branch. Those are the metrics in master branch, and that was the experiments we just run. It's the same actually, which is expected, but let's change something. In the parameters file, we have some hyperparameters. Let's change some of those. DVC exp-run set param train. Train estimators. Let's increase number of estimators. Let's say to, I don't know, 130. Oh. DVC reproduces the result with the new hyperparameter. And you can see the result in the table. So this is the master. This is our previous experiments, which is the same as the master. And that is the last run. So we run in only one command, and it's already on the history of your repository. It's in the history of your Git. But actually, it's not a part of your commits or branches. If you look at the branches, we don't see any new branches. We don't see any new commits. What actually happens under the hood, DVC creates a new, which is called custom reference, kind of a commit, but outside of your regular ones, and stores all the result of your experimentation on those commits. So it's kind of commit, but it's hidden from you. It's going to be hidden from your team members because it's on your machine only. So, all right, let's continue the experimentation process. Okay, 130 was not the best experiments. Let's try 150. and retrain the model again. So we got one more experiment, that one with 150. This is 150 number of estimators. And again, we got a new commit with a new result. And now we can decide which one is the best and what we should do about this, change. So this example was very simple. We just modify params YAML, right? But the best part of this approach, you can modify anything. For example, you can go to your code, src train, and modify part of your code. For example, let's do add one more parameter, depth, let's say 40. So I did modification in my code. I run one command. DVC creates kind of like snapshot, if you wish, kind of a virtual snapshot. And now we got a new experiment. So that's one. And that experiment happened with the code change, not just hyperparameter change, and with a new value, which is not the base, by the way. So we can probably choose another one. So when we decide, and we can keep going with these experiments, we can create like dozens and hundreds of experiments. Overhead for the experimentation part is relatively small. It's basically like commit with meta information plus data change if you have changed data before. Now you can look at the difference. You can use all the features that we were talking about before. For example, metrics diff. Metrics diff can show you the difference between the last committed change and the current change. So this was the previous value, and now we got here, which was not the best experiment, right? And the change was -2%. How about the difference with previous commit, for example? Yeah, that's the difference with the previous commit. And this is how you can navigate with all the metrics. For the plots, you do pretty much the same, but plot. So file was generated, file plot HTML. If you open the file, you'll see the difference between, in this case, between the previous commit and the latest experiment. This is recall precision and true positive to negative rates. So that's how the experimentation part works in a simple case. And again, the beauty of this approach that you can deliver this result to any automation tool that you have, to your training in a cloud, to your CI/CD process, to your dashboard that your team might have, or any other tools. So, but how about checkpoints, right? In this case, we were talking about not simple, but kind of more traditional machine learning when training happens from beginning to the end. In deep learning, it's not enough. In deep learning, we work a lot with model checkpoints. When model is changing, we track all the version of the models during the training process, because in some point we'd like to return back to one of the models. So this is another example of repository. It's also DVC repository with one simple step, just train. And but the difference is here we generate checkpoints. So let's see how it works. Say DVC run, and now training is starting. So this is the first epoch, and we created the checkpoints with about like 11% accuracy. And we keep working on our checkpoints, right? So now it's like 23% accuracy, and new checkpoint was created. 28%, almost 30. All right, let's say it's enough for now. So let's take a look at the experiment table in this project. This is how it looks like. Now you can see many experiments, and each of those experiments actually represents a checkpoint, right? For accuracy, this is the measure metrics here. It was 12% in the very first checkpoint, which is step number 0, then 50, and then we went up to 30% in the latest checkpoint. And all the checkpoints are stored in the Git history as ephemeral experiments, as ephemeral commits. And you have seen, I didn't run any like git commit or any other commands. So we can just continue the training part and keep improving accuracy until it's increasing. So 35, the next checkpoint, it's 40 in the current one. All right, let's look. So accuracy is keep increasing. So 36, 42 here, and we keep improving the making checkpoints. But what is important here? We can make some changes in hyperparameters or our code and train the model not from the scratch, but from the latest checkpoints with a good weights, with a good architecture of the network. All right, let's take a look at the params files and modify, let's say, dropout rate. All right, DVC expran set param dropout equals to, let's say, 125. All right. It starts with the previous checkpoint, which was 40%, around 40% accuracy, and we keep increasing the accuracy. So now it's like 50 something. Let's stop this process and look at the table. And this is what you see, what you can see here. We still improving the accuracy. We still keep making checkpoints here. But what is cool here, it's DVC recognizes the change. It's not just a checkpoint, the next checkpoint. This checkpoint is different, and DVC says you, yeah, it was a change, and you can look at this change. And with this information, you can not only keep track of all of your checkpoints, you can also make the entire process reproducible in a deep learning. So DVC keep track of all the checkpoints and all the experiments here. For example, you can just look at the difference between this checkpoint and that checkpoint, and Git has all the information. Let's do this. Let's look at the difference in the command line, and in a Git, you can look at the difference between checkpoints, let's say in a params file. So you see, Git, all this information was tracked by Git, and everything is in the Git history. So that's how we implemented the experimentation part in DVC with the ephemeral commits, and this kind of explains you can apply deep learning. How you apply DevOps principles and software engineering principles in your ML training process. So what what is great about this approach of using like Git under the hood on your experimentation tool set is benefit that you can get from Git itself, Git services such as GitHub and pull requests and issues in a GitHub, as well as CI/CD systems and cloud. So you are basically benefiting from the entire DevOps ecosystem using the Git under the hood. And in this approach, we just show that this is possible. This is possible to efficiently track your experiments with a Git, including checkpoints, models, and data sets. If you do this carefully, if you not create overhead to the repository. So that's what I have for today. Thank you for your attention, and please don't be lost on your experiments.
Awesome, thank you, Dmitry. That was really insightful. Like I liked very much that there is a way to make comparison of the metrics between the commits. That's really seems to be amazing. Just to follow up with the concept. So in the data version control, as I understand, and correct me if I'm wrong, there is a file that acts as an index to the data source. So yeah, so my question is, if the data is in this source, in this path, is being changed, like it's changing, is it still being controlled, or the like there wouldn't be a way to actually control this versions of the data if it's expanding? Let's say it's a transactional data and it's being fed over the time. So is it still controlled, or that would be different?
So there are many parts in this question. If you're talking about data, just data, right? Data sources or labels. Then yeah, so DVC version everything on a file level. If you add a new file, DVC keep track of all the files. If you modify file, DVC adds additional file, and so it will keep track of all the versions of the files. In case of experimentation, it works this way. Each checkpoint, each weights file is going to be a separate file, and they live on your machine until you ask DVC to push those to cloud. So you need to say, all right, I like this experiments. I'd like to make an actual, not ephemeral, but an actual commit from this experiments, and I need to push data, which means all the checkpoints.
Yeah,
to the cloud.
So Kaniska is asking, like, showing interest in the topic, and they're asking if there is a link or a Twitter account that they can reach out to you or something like that. So yeah, for DVC.
I send the link to DVC work Twitter. You can find from the Twitter. You can find the website and DVC documentation. We have a very great document. We put a lot of effort to put for the, and there are tutorials like getting started, for example. Let me copy the link here. This is tutorial for the first part of my demo.
Right.
When you can find a project and kind of step by step create the project and run experiments on the projects. Awesome,
that's great. Thank you. I think we're over time now. Thank you for the insightful tool, and definitely, like, I didn't know about it, and definitely I'm going to use it. So thank you for that.
Yeah, thank you.
All right, have a good one. Bye, everyone.